Okay, this is your Edpuzzle video for Skill Builder number 2 for solving systems of equations. We're going to go through a few examples and you'll have some opportunities to practice. So first we're going to start with example 1 where we're going through the equal values method. With this system we can see here that we've got x equals negative 2y plus 16 and then x equals negative y plus 2. So with the equal values method, that just means that since both of these are set equal to x, we can set them equal to each other. So when we solve this, we can write it out as negative 2y plus 16 equals negative y plus 2. Okay, so then we can just go through and solve for y. So we are going to add 2y to both sides. When we do that, we cancel on the left side and we're left with 16 equals negative y plus 2y is just a positive y plus 2. So then we're going to subtract 2 from both sides. So we'll cancel the 2 out on the right side and we'll be left with y equals 14. Okay, so we're not done yet. When we're solving a system of equations, we want to make sure that we solve for both the x and the y value. We have the y value here. Now we need to solve for the x value. To do that, all we're doing is plugging it in to either one of these equations. Either one will work. You should get the same answer with both. I tend to choose the one that looks a little more complicated, and so I would probably go with this bottom equation right here. We're looking for our x value, so we'll leave that as x. Equals, now we can take the 14 y value and plug it in over here for this y. So we've got a negative 14 plus 2. So then negative 14 plus 2 is going to equal a negative 12. So then our answer here will be negative 12, 14. Okay. The equal values method will work whenever you have x equals the rest of this, x equals the rest of this, or y equals all of this and y equals all of that. That's a very easy way to solve it. Just set them equal to each other. So now, moving down to example 2. Now we're looking at the substitution method. The substitution method is fairly similar to the equal values method in that you're kind of substituting in for a variable. So here we've got 4x plus y equals 8 and then x equals 5 minus y. So substitution works really well when you've got one of your variables isolated. So for example here we've got x equals this stuff over here on the right. So we're going to substitute all of this in to the first equation. So let's go ahead and do that. We've got 4 and we're substituting in here for the x. So x equals 5 minus y. We're going to take this 5 minus y and put it in here for the x value. And then we'll just write out the rest of that top equation. Okay, so now we can go ahead and solve for y. We've got 4 times 5, which would equal 20. 4 times a negative y would be minus 4y. And then the rest of the equation, plus y equals 8. So then on the left side, when we collect like terms, we've got 20. Negative 4y plus y is going to give us a minus 3y equals 8. Okay, so then we're going to subtract 20 from both sides. So we can start to isolate that y. When we do that, these will cancel. We'll be left with a negative 3y on the left side equals 8 minus 20 is going to be a negative 12. Okay, so then when we divide both sides by a negative 3, these will cancel and we're left with y equals 4. Okay, so again, we're not done because we need a value for our x and for our y. So just like before, we're going to go ahead and choose one of these equations here to plug it into. The bottom one looks a little bit simpler than the top, so I'll go ahead and choose that one. So x equals, because we're looking for our x value, 5 minus, and this is where we'll plug in that y value that we just found. Okay, so x is going to equal 5 minus 4 is 1. We've got our x, we've got our y, and we can write them as a coordinate pair now. And that's our solution. Okay, so then now we're going to move on to the back side. We're going to go to example 3, where we're using the elimination method. This is probably the more complicated of the methods, but it's the best way to not be working with fractions as often as we can. Okay, so elimination is great because it basically starts you out by eliminating one of your variables so that you can solve for the other variable. So here, what we need to do when we look up here is figure out how we can get the same number, the same coefficient in front of our y's or in front of our x's. One of them has to be positive, one of them has to be negative, because ultimately we're going to end up adding straight down to eliminate one of our variables. So let's go through this example. Here, when I look at both of these equations, I can already see that there's no way I can multiply the top through by anything to make it equal anything on the bottom. Same thing with the bottom to the top. So I'm probably going to have to multiply both of these equations by something. The next thing I probably look at are the signs. Well, here we've got a plus, here we've got a minus, so I'll go ahead and look at those y values, or those values right in front of the y. So I'm going to go ahead and multiply the top. Looks like 3, 4. The least common multiple there would probably be 12. So I'm going to multiply the top by 4, and I'm going to multiply the bottom one by 3. So when I do that, those are going to give me new equations. I'm going to make sure I distribute correctly when I do this. So 4 times 2x gives me 8x. 4 times 3y gives me plus a 12y. And then 4 times 10 equals 40. So then doing the same thing on the bottom with the 3, we've got 3 times 3x gives a 9x. 3 times negative 4y gives a minus 12y. And then 3 times a negative 2 gives a negative 6. Okay, so now we can see with our coefficients in front of our y's, we've got a plus 12, we've got a minus 12. When we add those together, which is what we do in elimination, they're going to cancel each other out. So for elimination, we're just going to add straight down. So 8x plus 9x equals 17x. 12y minus 12y, or 12y plus a negative 12y, is going to give us a 0. So that's where the elimination is happening. And then over here, 40 plus a negative 6, or 40 minus 6, gives us 34. So we're left with 17x equals 34. So now we'll divide both sides by 17, and we'll cancel here. So x is going to end up equaling 2. Okay, we're almost there. Again, we need to have a value for our x and a value for our y. So we're going to take this x equals 2, and we're going to go ahead and plug into either one of these over here. I'm just going to go ahead and choose the top one. You don't have to plug it into the one where you multiply by the 4. Just plug it into the simpler one over here. So we'll plug it in. We've got 2 times our x value is 2, so this is where we're going to put that 2, plus 3y equals 10. So now we can solve for our y value. 2 times 2 is 4, plus 3y equals 10. We're going to subtract 4 from both sides. Those will cancel. We'll be left with 3y on the left side equals 10 minus 4, which is 6. We divide both sides by 3, and we'll end up with y equals 2. So our solution for this system will be 2, 2. And that's our final answer.